When Hurricane Juan first blew through Point Pleasant Park, it resulted in a complete mess, and it affected the First Nations severely because Point Pleasant Park is an important traditional place, spiritual gathering, and it's where they first interacted with French settlers, and is also known to be a burial site. Now, some complications that come with looking at the restoration of Point Pleasant Park after Hurricane Juan had struck was time and biodiversity. So, how long it was going to take for complete regeneration, and also what that kind of regeneration was going to look like in terms of organisms, plants, and again, just total biodiversity. So, our objectives in the study surround how Point Pleasant Park as a whole and in parts are affected by Hurricane Juan. And with that, our hypothesis is that secondary succession leads to an increase of overall forest community, and the density of the dominant species changed from one species to another, and that each community metric has increased.
Our hypotheses for the main three research questions were as following. For research question 1, total species density will increase following Hurricane Juan in 2004, creating increased crowding in the overall forest community as it moves towards a climax community. For research question 2, as the community moves towards the climax community, the ratio of red spruce and maple will stay constant. And for research question 3, over time, species richness will increase as the forest community continues to recover from the effects caused by Hurricane Juan.
Point Pleasant Park's forest canopy was uprooted and damaged due to the high wind speeds produced by Hurricane Juan. Shown in Figure 1 are the 6 study sites selected during a survey of the park's forest. These specific sites were chosen based on the severity of conflict damage to the forest structure, with a local total area of 400 square meters for each site. The study began in 2004 and continues to run to the present day. Some years are excluded from the study due to other hurricanes and the COVID-19 pandemic. Therefore, no data was collected. Ecology students during the fall semester went to Point Pleasant Park to gather data at their specific site. The data collection occurred during the end of October into early November. The size of the trees were measured using measuring tapes and the technique of diameter breast height, DBH, where DBH was measured 4.5 feet off the ground. This is a standard unit of measure and practice by the logging industry. Only living trees with a minimum diameter of 2.5 centimeters were included. The tree density was also surveyed at each site, which is the number of trees belonging to each species. Data from tree density and diameter breast height, DBH, can be processed and turned into graphs that compare diversity over time and density over time. The results were analyzed further using linear regression formulas to determine the presence of a correlation as well as the strength of a relationship between these variables. These outcomes help evaluate the estimated effect Hurricane Juan had on Point Pleasant Park's forest community. We will be focusing on the results from total density, red spruce density, red maple density, and species richness, to explain how much influence these factors have on the forest succession.
As a recap, the first research question is, how has the overall forest community changed over time? What can we predict will happen to the overall community as the forest moves towards its climax community? And here are the results of that. What we understand from this graph here is that over time, the density of the community has grown linearly, leading to much more trees within the 400 meter square range in the later years after the impacts of Hurricane Juan. Why did this happen? Since Hurricane Juan ruined most of the Point Pleasant Park area, there's not a lot of plants still inhabiting it, leading to low predation and competition, meaning a lot more plants can root and thrive in this environment. What we can predict in the future is that as the forest moves towards its climax community, the density graph will begin to plateau, eventually leading to an equilibrium of trees, meaning that it can sustain the population in that environment. As we can see, around the 2004 range, there was a density of about 0. And in 2025, we can see there's about 250, which is a big difference.
Research question 2, how has the density of the dominant species in 2004 changed over time, and what can we predict will happen to the dominant species as the forest moves towards its climax community? So a linear regression was conducted to determine the relationship between the red spruce and the red maple richness to the years following Hurricane Juan. And so as you can see in figures 2 and figure 3, that the density of both the red spruce and the red maple had increased from below 5 to over 25 and more, 400 meters squared from 2004 to 2025. So what does this mean? So essentially it means that there was in fact an increase of the dominant species red spruce and red maple from 2004 to 2005. If you look at the R-squared values for both red spruce and red maple, they're around 0.13. So this is relatively low, but it's positive. So that means that there is going to be an increase of density for these dominant species over time as it moves towards its climax community, but it's just going to take a little bit more time and it's not going to be fast.
Figure 4 illustrates how species richness is increased during the study. Using linear regression, the overall length between species richness and time was examined. The results produced an R-squared value of 0.58, indicating that 58% of the variability in species richness is correlated with time. In addition, a p-value of less than 0.05 was calculated. Therefore, it can be concluded that these results are statistically significant, and there is a strong positive connection between this measurement of diversity with respect to time. As well, an increase in species richness following a disturbance, which is displayed by the dotted trend line in Figure 4, aligns with the successional theory's projected path that richness will increase as the developing community makes use of newly available resources. Therefore, based on these pieces of evidence, I can predict that species richness in Point Pleasant Park will continue to increase, moving towards its climax community. Additionally, Figure 5 is a proposed model of forest ecosystem recovery following a disturbance. Focusing on Phase 2, labeled aggradation, there is a significant increase in biomass during this phase of recovery. Comparing the dotted trend line in Figure 4 to the slope of the line in Figure 5, there are obvious similarities, which could place Point Pleasant Park's recovery somewhere in Phase 2. As well, an increase in abundance of trees in Point Pleasant Park is equivalent to an increase in biomass. I can conclude that the increase in species richness signifies a more diverse environment. Comparing now with the changes in Point Pleasant Park's forest community, being consistent with the trends described and the successional theory, this indicates that as the forest moves towards its climax community, it is in simultaneous recovery. My findings partially support my original hypothesis that species richness will increase as the forest community recovers. However, once the forest reaches its climax community, species richness will, instead, stabilize and then fluctuate from time to time. This is shown in Figure 5 during the final phases.
So, in conclusion, Point Pleasant Park is currently at a mid-successional stage. Looking into the article called Forest Ecosystems of Point Pleasant Park by Lilly in 2004, they state that an area that is dominated by red spruce, balsam fir, white birch, and red maple is actually a very popular trend that follows during a mid-successional stage. Also, Point Pleasant Park being an urban park actually slows down the rate of succession, and this can kind of be compared to looking at the article of the process of natural selection in urban areas by Zipperer. Basically, a study was conducted through this article where scientists went in and gathered data from the wheel wells as well as footwear from people and vehicles from a popular park. And they were able to extract a large amount of seeds that had came from the wheel wells and from footwear. And so, essentially, footwear is known to be a secondary dispersal, as well as vehicles. So basically, they take the seeds and carry them further than where they're actually naturally selected to go. This can be compared to results number 2 when you look at the increase of linear regression from 2004 to 2015. Then just after 2015, there's quite a significant drop of richness. And this is because after Hurricane Matthew in 2016, there would have been a lot of vehicles and there would have been a lot of people and footwear trying to help clean up the damage. Then again, taking a lot of the seeds through secondary dispersal and removing them from the park, therefore leading to decrease in richness and diversity. And so a way that we can kind of look into enhancing our populations and restoring the Point Pleasant Park in general by looking at it through Mi'kmaq or the Mi'kmaqi way or First Nation way could be through enhancing biodiversity, where almost half of the world's endangered mammals live on protected land of Indigenous people, and the rates of deforestation of land that is occupied by Indigenous people have lowered. So this all results in a higher biodiversity compared to land owned by non-Indigenous people. And so addressing Indigenous claims, upholding existing land tenure rights, and resourcing programs on Indigenous managed lands by Broom et al. 2023, this can really be a positive way to look at a better way that Point Pleasant Park can increase biodiversity and can hopefully restore to its natural way again after hurricanes.
We want to express our thanks to the fall students who went into the field and collected data each year for this study, as well as Christine Bonecamp for initiating this research project. We appreciate the work done by Allison Schmid and Joanna Zagoras, who made the graphs and calculated the statistics used throughout the presentation. Additionally, we want to thank the Mi'kmaq people for the use of their traditional and ancestral territory. Thank you.
All of our references are in CSE format as indicated in the assignment for a forest ecology research presentation, guidelines, and instructions. How will climate change and the more frequent disturbances with it affect succession? Can we expect succession to advance the same way as it has in the past? Climate change has already started impacting how succession works. For example, climate change causes higher temperature and a change in frequency of storms and other disasters. This increased number of storms will uproot ecosystems more frequently and restart the process of accession from the beginning. There is also no guarantee that the forest will grow in the same way that it did in the past after one of these storms happened.
For this question, red spruce and red maple are two of the species that bounce back quickly after a major disturbance, like Hurricane Juan had on Point Pleasant Park. This comes from work specifically in Halifax and the Acadia Forest region, such as studies like Lilly et al. 2004, Keyes 2004, and LePay and Friedman 2010, who all describe how these species behave in wind-disturbed forest systems. Starting with red spruce, one of the biggest advantages is its shade tolerance. After Hurricane Juan opened the canopy, there was a flush of new growth, but as the forest thickened again, spruce seedlings survived under lower light conditions. They do not get out-competed right away as the canopy closes again. Red spruce also has very high seedling survival in moist, mixed wood soils that are common across Point Pleasant Park. Red maple, on the other hand, recovers quickly for almost the opposite reason. It has extremely fast regrowth, and many studies in Nova Scotia show that it can sprout from damaged stems or roots after being blown down or snapped. That allows it to take advantage of new light from canopy gaps much earlier than slower growing species. Red maple is also considered an early to mid successional hardwood, which lines up with what we see in the long-term Point Pleasant Park data. Its density rises quickly in the years right after Hurricane 1. Together, these traits explain why both species make strong recoveries. Red maple gets into early through quick sprouting, and red spruce persists over the long term as it can handle the lower light conditions that develop as the stand matures.
How do you think the site's proximity to the ocean has affected its succession in plant populations, if at all? Well, according to numerous studies found, forests that are close to the sea are found to have a strong correlation with succession. And this is because of relationships between forest greenness and sea temperature, as well as tree rings and ocean climate. Another influence of forest succession from the ocean is marine aerosols, which are airborne particles that carry nutrients and are blown onto land due to the climate, resulting in forests receiving rich and abundant nutrients that promote growth and succession.